So what if I told you that the future of clean water? Well, it depends on tech that's about 1 billion times smaller than a water bottle. It sounds like science fiction, right? But today, we're going to dive into how nanotechnology is completely revolutionizing our water filters, giving us a powerful new way to fight off invisible pollutants. First things first, let's set the stage. You probably think the water coming out of your tap is pretty clean. I mean, it looks clear, right? But here's the thing. There's often an invisible problem lurking in there. A whole new class of pollutants that our current systems were just never, ever designed to handle.
These things are called emerging contaminants, or ECs for short. And we're talking about all sorts of stuff. Trace amounts of prescription drugs, chemicals from lotions and sunscreens, industrial runoff, pesticides, you name it. The real issue here is that they're persistent. They just don't go away. Conventional water treatment plants can't grab them, so they slip right on through and end up back in our water.
So why are they so tough to get rid of? What makes them so sneaky? Well, it really boils down to two things. They are incredibly small, and their chemical structures are super complex. You can think of them as microscopic escape artists, just dodging and weaving through the very systems that are supposed to catch them. And that is a huge challenge for our entire water infrastructure. Okay, so to really get why this new tech is so important, we have to talk about the biggest headache with our current best technology. This brings us right to a really fundamental problem in water filtration: clogging. You know, right now, one of the best tools we have is called membrane filtration, and the idea behind it is actually super simple. Just picture a coffee filter, but on a microscopic scale. It's basically a physical barrier with these teeny tiny pores that block stuff based on size and only let the pure water molecules pass through.
But, and you knew there was a but, here's the catch. On the left, you see the dream scenario. A brand new filter, water is just flowing through, everything's efficient. But over time, as you can see on the right, all those contaminants it's catching start to pile up. They clog the pores. This whole process has a name. It's called fouling, and it is a massive, massive issue. It slows the water flow to a crawl, which means you have to crank up the energy to force the water through. That drives up costs, and eventually, the filter's just toast.
So, how in the world do we solve this fouling problem and catch those tricky emerging contaminants at the same time? Well, this is where our story gets really, really cool. We're talking about some tiny tech that is making a truly big impact.
We are talking about nanomaterials. See, when you shrink materials down to this tiny scale, they start to get these unique properties. You could almost call them superpowers for filtering water. Their surface area becomes immense, which gives pollutants way more places to get stuck. They can be engineered to be more chemically reactive, so they don't just catch contaminants, they actively break them down. And their ability to just soak up pollutants, it's off the charts. They're like microscopic super sponges.
Now, there are a few different types of these nanomaterials that are really leading the charge, and each one has its own special set of skills. So let's meet the 4 main nano-warriors that scientists are developing for our water filters.
First up, we've got graphene oxide, or GO. Think of this as an atom-thin sheet of carbon. I mean, it's unbelievably thin. This 2D structure gives it a massive surface area for grabbing pollutants. Plus, it actually loves water, which is great for improving flow. The downside? It's not always stable, and yeah, it can be pretty expensive to make.
Next, we have carbon nanotubes, or CNTs. These are the reinforcers of the group. They're crazy strong, so you can embed them in a filter membrane to make it way more durable. And their hollow tube-like shape creates these little superhighways for water molecules to zip through, which dramatically speeds up filtration. The big questions here, though, are about potential toxicity and, you guessed it, high production costs.
Our third nano-warrior is something called metal organic frameworks, or MOFs. These guys are the precision specialists. They are like microscopic cages that are custom-built to trap very specific molecules. Because you can actually tune the exact size and shape of their pores, you can design them to hunt down and capture one particular contaminant with incredible accuracy. But all that custom design makes them, complex and costly to build.
And finally, let's meet MXenes. They're a relative newcomer to the scene, but they are a seriously powerful all-arounder. Just like graphene oxide, it's a 2D layered material, it's extremely hydrophilic, so it attracts water, and it's electrically conductive. That combination gives it absolutely fantastic resistance to that fouling problem we talked about. Its main weakness? It's prone to oxidation. Basically, it can rust, which can limit how long it lasts. Okay, so let's do a quick roll call of our nano-warrior team. We have graphene oxide, the super absorber. We've got carbon nanotubes, the reinforcers.
MOS are our precision specialists, and MXenes are the awesome anti-fouling all-arounders. Every single one offers a unique advantage, but also a unique challenge that we've got to figure out.
So the big question is, how well does this stuff actually work in the real world? Well, get this. Studies have shown that some of these nano-enhanced membranes can achieve over a 99% rejection rate for certain pollutants. We're talking near-perfect removal. That's just incredible.
And it's not just about what they remove, it's about how fast they do it. The technical term is water flux. It's how much water gets through a filter in a certain amount of time. And some of these advanced MXene membranes have shown a water flux 30 times greater than older graphene oxide designs. 30 times! That is a mind-blowing leap in efficiency. Okay, this all sounds amazing. It really does. But it brings us to the final and maybe the most important question. When can we actually start using this stuff? So let's take a look at the hurdle standing between this incredible lab technology and, say, the faucet in your kitchen.
There are really three main roadblocks. First, as we've already touched on, the production cost is still really high. Second, it's one thing to make a little bit in the lab. It's another thing entirely to scale it up to an industrial level. And third, we have to be absolutely sure about their long-term environmental safety, right? We can't solve one contamination problem just by creating a new one down the road.
So getting past these challenges is going to take a bit of a shift in thinking. The future isn't just about stumbling upon the one perfect nanomaterial. It's really about designing these entire systems in a much, much smarter way. And to do that, scientists are turning to a very powerful new ally.
And that ally is artificial intelligence. AI and machine learning are totally changing the game here. Instead of just endless trial and error in the lab, AI models can now predict how a brand new material will perform before anyone even makes it. Machine learning can analyze data in real time to actually anticipate and prevent fouling before it starts. And maybe the most exciting part, AI can sift through massive databases to speed up the discovery of totally new combinations of nanomaterials, helping us find cheaper, safer, and better solutions way faster than ever before.
Which brings us to this final, really cool idea. What happens when you combine these powerful nano-warriors with a smart, predictive AI? You see, we're not just talking about a better filter anymore. We're talking about an intelligent system, a system that can optimize itself, a filter that thinks. Could that be the key to ensuring clean, safe water for every single person on the planet? It's a huge question, and honestly, the answer could literally change the world.